Okay, so what I'm going to do in this video is I'm going to go over some function problems. What I've found is my kids have difficulty with function problems. Most of it can be done on the calculator. That and calculus seem to be the toughest, calculus and trig, but whatever. Let's do some problems. Get going here. Okay, so consider the graph of the function y equals f of x defined below. Okay, no problem. Kind of an interesting function there. Write down all the labeled points on the curve that are local maximums. Okay, so local maximums are going to be any point where the gradient is going to be equal to 0. And now, if we're going to look at local maximums, what we'd see, this one right here is a local maximum, B, and this one right here. Now, the key to local maximum and minimums, they don't necessarily have to be the highest or lowest point, but they're where the gradient is going to be equal to 0 in both of these points, okay? So if this was a calculus problem and you took the derivative, you would find, these would be your local maximums right here, where the function has its least value. Now, some kids might look at this and go, oh, okay, well, D, the local minimum, is the least value, but that's actually not the case here. It's H or H, whatever you want to say. So it's H right there. And then where the function attains its greatest value. Okay, well, again, the greatest value is, in this case, it is a local maximum, but it's f. And then where the gradient of the tangent of the curve is positive. Okay, well, if we think about gradients, if it's like this, I used to have my kids do, gradient calisthenics. So think about this. That's a positive gradient. A negative gradient looks like this. Okay, and then, of course, zero gradient. No gradient is a flat line. All right, so in this case, what we're looking for is positive. Well, positive is going to be going up here, and then this one's slightly positive here. We have negative going down here. We have negative going down here. B, F, D are, those are local maximums and minimums, so they're not anything. Or, well, they're not. Their gradient is 0, so it's not positive or negative. So in this case, positive would be A and E. All right, cool. Now, and then part E, it says where f of x is greater than 0. Okay, so that means where the function's greater than 0 here. So we're looking at all this. That gets rid of D, G, and H right there. And the derivative of x is less than 0. Okay, so again, this is just another way of writing a negative gradient here, where the derivative is negative. That's a gradient. Okay, so we're going to, again, look for, in this case, we're going to look for negative. So in this case, we're going down here. That's greater than 0, and it's negative, so C would work out for us. Okay, and then let's see what we got here. Now, some kids would put G here, but you got to be careful because they say, f of x is greater than 0. So G is not going to be any good here. So that's kind of a trick one. They're just, because they gave you two constraints here. So it's only going to be C. So that's just kind of goes over all the main things in terms of, local maximum and minimums, greatest value, least value, where the gradient's positive and negative, just to start off. And I will move on to another problem from here. Okay, so for the second problem here, it says on the grid below, sketch the graph of the function f of x equals 2 times 1.6 raised to the x power for the domain 0 to 3. Okay, so, it's very common what they do here is they, give you a function and then they, restrict the domain, which is actually kind of nice. So 2, I'm going to put it right in here just to get started here, raised to the x power. Okay, now they're going to restrict the domain here, so I'm just going to go ahead and restrict this from 0 to 3 and see what it looks like. Okay, so it's going to be an exponential function, so you see that it's slowly rising there. Now, what they want us to do is sketch that. Now, sketching, they're going to want the y-intercept, and so what I'm just going to do is I'm going to go to the table. And I see 0 is 2, 1 is 3.2, 2 is 5.12, 3 is 8.19. So what I'm going to do right now is I'm just going to go ahead and plot those points. Okay, so what I did, I went ahead and plotted those points. And now what I'm just going to do is I'm going to make a smooth curve here to finish it off. Okay, so that's the first thing right there. So you can basically get that off your calculator. And this is what I'm talking about with a lot of these problems. You can use your calculator and just if you know your functions pretty well, like on the calculator, in terms of like finding the table and things, it makes it pretty easy. Okay, so now it says write down the coordinates of the y-intercept of the graph of f of x. Well, okay, that's easy. It's right here. The y-intercept is 0, 2, and you'll see that it was 0, 2 there. So we're going to put, 0, 2 right down here. Where is my, oh, there it is. Okay, 0, and then 2. All right, cool. Now, on the grid, draw the graph of g of x equals 5 minus 2x. Okay, well, 5 minus 2x, that's going to be, what is that going to be? It's going to be a line, okay? So 5 minus 2x in the same domain, obviously, okay? So let's go back up here, go to y equals. We can put it in here as well, and it's going to help us in a second, you'll see. 5 minus 2x, and then let's graph it. Oh, okay, so it's a line right there. Okay, so what I'm going to do again is I'm going to look at the table, and you can see that y2 right here. So we have 0, 5, 1, 3, 2, 1, 3, negative 1. Okay, so I'm gonna graph those points real quick. Okay, so I got that done. Now again, just make sure that you use a ruler. I don't have a ruler on this stencil, and I don't feel like drawing lines. So anyway, it's a straight line that goes negative down right here. Okay. All right, so now use your graphic display calculator to solve f of x equals g of x. Okay, now you got to be real careful for this. Okay, so what they're saying is, if they're going to do f of x equals g of x, okay, what they're saying is, 2 times 1.6 to the x power equals g of x, which is what, 5 minus 2x. Okay, now you can use this, you can do the solver, use this, solve this using the solver. Like if you moved everything over to make it equal to 0, you could do 2 times 1.6 to the x power and just move everything over. So it'd be plus 2x minus 5 equals 0. Okay, so we can do that and put that in the solver. We can also use it on the graph as well. So let me do it on the graph first. Okay. So we have our graph here, and we just basically want to find the intersection here. Okay, so we're going to go second, calculate, and then we want intersection, which is right here. Okay, and you just go towards the intersection. Okay, so first curve, we're on the first curve right now, obviously, because it says first curve. Boom, second curve, boom, and then guess, boom. And then, okay, so now the x is 0.942. Now, it doesn't ask for the point of intersection. It asks for... it asks you to solve it. So anytime it asks you to solve it, it's actually asking you to find the x value. So our x value there is going to be 0.94, and then around it's going to be 3. So this answer is going to be 0.943. Okay. Now you can also enter this in the calculator as well. This is, especially with exponential functions, it's a really good if you know how to use a solver. So let me just put this. Let me move it over so I can see. Okay, so what did I do there? I went math, and then I arrowed up, got the solver, boom. Okay, so what do we got here? So 2 times 1.6, comma, raised to the x power, and then I'm going to say plus 2x minus 5, okay? And then the thing here, it gives you the answer here. But if you've done problems on this before, like it won't give you the the answer right away. So you have to do alpha solve and whatever. It's alpha solve. It's right there. So 0.943. So everything's good. And that's 2 ways to do it. So I tend to do, with exponential functions, I tend to use the solver, especially since like what the, if you have a function, I don't know, we'll just make up a function. Let's say you had something like, I don't know, 3 to the x power plus 20 or something. I don't know. The way these questions always work is they'll ask you, oh, find when x is, 4, find when x is 7, and then they'll give you f of x. And the best way to do that is just, when they give you f of x, so let's say find when f of x equals 5,000. So you can just plug in 5,000 here. You have 3 to the x power here plus 20, 20, wee. Okay, and then subtract 5,000. You always make it equal to 0. Okay, my kids are pretty good at this. I've kind of drilled it in a little bit. I think they intuitively understood it. And then, you could enter that in. I don't even know. I just made that up off the top of my head. It's probably some goofy number. So again, well, it's a good point here. So if you need to get back and do it again, go up here, press clear, and do 3 raised to the x power minus 4980. What do we got? 4980. And what do we got? And then see, you have the same answer there, so you got to do alpha solve, blah, blah, blah. 7.75. Okay, so it worked out all right. But that's, because we don't use logarithms in this course. So it's something, using the solver really helps you out. Okay, so that's another problem. Not a bad one. Let's try a third one. Okay, so for this problem, this one was a kind of a tricky one. Even I looked at it the first time, I was like, huh? A small manufacturing company makes and sells X machines each month. The monthly cost C in dollars is given by that. C of X equals 2600 plus 0.4 times X squared. Okay, so this is a quadratic function. The monthly income in dollars obtained by selling the machines is given that. Okay, profit is monthly by selling X. Profit, P of X, is the monthly profit obtained by selling X machines. Find P of X. Okay, well, first of all, you need to understand that profit, okay, now, I don't know, this is the part I thought was kind of, it's income minus cost. Now, I mean, it's intuitive, but if you're not taking business, some kids might not know that. So in this case, I'll do it over here. So P of X equals, income, so income minus cost. Okay, so 150x minus 0.6x squared minus, okay, and then 2600 plus 0.4x squared. Okay, now you have to distribute that negative, so what we're going to get here is P of X equals 150x, and then you're going to get minus 0.6x squared minus 2600, and don't forget to distribute to there too, so you get 0.x squared. Okay, now if I'm going to write this in order just because I think it's going to be easier. So it's going to be, let's see, if we have that and that's negative x squared. Okay, negative 1x squared, or just negative x squared, plus 150x minus 2,600. Okay, so just looking at that, I see the negative in front of the a here, or negative a coefficient. This is going to look like, whoa, okay, it's going to be a parabola, not quite like that, but it's going to have a maximum right here. Okay, now I never understood these quadratic models for business functions, but whatever, they use it all the time. Because the more you produce, the less money you make. It doesn't make any sense. Normally in the real world, it's not like that. But whatever, let's move on. So find the number of machines that should be made and sold each month to maximize P. Okay, so we need to find this point right here. We actually need to find the x-coordinate of this point. Now, there's a very easy formula to find the x-coordinate of the vertex. I'm going to show you 2 ways to do this. So you can find x equals negative b over 2a. So in this case, it would be negative 150. Over, that's negative 1, so 2 times negative 1. Okay, so that's going to be negative 50 over negative 2. That's 75. So you need to sell 75 machines. Okay. Now, you can also, this is a maximum problem, so you can also take the derivative of that. So let me show you that real quick right here. So if we did P prime of x, it would be negative 2x. Plus 150. Now we want to make it equal 0 because it's a maximum. The gradient is 0 to maximum here, so if you want to use calculus on this, you could. Okay, so you get negative 2x plus 150, move the 150 over, so you get negative 150 equals negative 2x, blah, blah, blah. Divide by negative 2, and lo and behold, you get 75 again. Sweet. Okay, so 75 machines, okay? Either way, it doesn't matter, or you could actually go on your calculator. The only problem with it going on the calculator and looking on a graph with this is the numbers are really big, so you're going to have to play with the window. I'm not going to do that on this one. I'm just going to go straight algebra on this one. Okay, so use your answer to part B to find the selling price of each machine in order to maximize the profit. Okay, now this is where it gets a little dicey. Okay, so what we need to, in order to find the selling price of each machine, okay, what we would need to do is, find out, the total income, okay, the amount of money they get from selling 75, and then divide it by 75, okay? So we gave this on a test, this problem, and it didn't go very well. I'm going to be honest with you. Okay, so you have to sub 75 into here. So, I of 75 is going to be 150 times 75 minus 0.6 times 75 squared, okay? So, I of 75 is going to be, what is it? It's actually going to be the maximum point as well. So let's do this. It's going to be, let's see, 150 times 75. Okay, minus, whoops, minus 0.6 times 75 squared. Okay, and you get 7,875. Okay, so 7,875, and then we're just going to divide that by 75. 7,875 divided by 75, which I think, if I remember correctly, it is 105. Okay, so divide by 75, and you get 105. Yeah, so it's 105. Okay, it's cost in dollars, so it's $105. Now, the mistake kids made here, and it's pretty legit, is they took the max here. But see, that's the problem. That's your profit, the maximum. So they took the maximum. I think it's 3,000 something or other, and they divide that by 75. They got 40 and change. So that hey, listen, this problem's pretty difficult. You can see this is a specimen paper. You can see it's number 15. So that's normally one of the harder problems, okay? So anyway, the important thing I would take out of this is just being able to find the maximum right here. Often these problems will ask for a maximum or minimum value. I don't know, this is kind of a different one. Hopefully I explained it all right. If not, move on, man. All right. Sorry about that, if I didn't, by the way. Okay, let's try a couple more that are a little more complicated, with some asymptotes. All right, in this problem, what we're going to deal with here is we're going to deal with horizontal and vertical asymptotes. You can always see that when there's an X down in the denominator here. The vertical asymptotes for IB curriculum, now what's an asymptote? If you don't know, so you have your X and your Y, okay? So your X here, your Y here. Basically a vertical asymptote. Now, if I've already done this problem before. What's going to happen here is this function is going to look like this. Okay, so the horizontal asymptote in all IB problems, according to the syllabus, is going to be x equals 0. So basically the function goes all the way up towards 0, but it cannot become 0 because you can't have 0 on the denominator here. Okay. Now, as x gets bigger, what's going to happen here? It gets smaller and smaller, but it's never going to be equal to 0. So it's going to, your horizontal asymptote is going to be y equals 0. Okay. Now, you can see this when you put it on a calculator. Okay. So, like, if we put this, this problem on a calculator, we'll go. Okay. So I need to clear all my stuff here. Okay. So I get 1.5 divided by x. Okay, you can see, what do they want it from 0 to 10, right? Okay, so we'll do my table set and just go from 0 to 10 and just graph it and let's see what it looks like. Okay, so it looks exactly like I said here. Okay, now the key here is if you look at the table. Okay, so at 0, x equals 0, there's an error because you can't have a 0 right here. That's a vertical asymptote. And then at 1, 2, see how it's getting closer and closer and closer to 0? It keeps going down, 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 down. It's never actually going to hit 0. It goes on for a long time, okay? So that's the key to notice about that. So anytime you see a problem like this. Now, you can see that in the graph, okay? Like if we go back to the graph, you can see it's getting closer and closer to 0, but it's not going to get to 0. And they're only concerned with, above 0 here. So, if this was negative, it would be over here too. So, Let's, or actually it'd be down. No, it wouldn't. It'd be down. Let's see, negative points. It'd be negative. It'd be down over here. Okay, it doesn't matter. Okay, so let's see. Use your GC to draw the graph. Okay, well, I'm gonna be honest here. I'm not gonna spend a whole lot of time on this. You can plot the points if they ask you to plot the points on a test. Whoops, we don't want that one. If they ask you to plot the points on a test, go to the table and plot the points right here, and you can draw the curve. I'm just going to give you a sketch here. Okay. Now, what happens as x gets closer to 0? Well, the function is y is getting bigger, right? Y is getting higher, okay? And then what happens when x gets closer to 10? Well, as x gets closer to 10, x is getting smaller towards 0, right? Okay. Now write down the equations for the vertical and horizontal asymptotes. Well, I've already done that, okay? So x equals 0 is the vertical asymptote, and y equals 0 is horizontal. Okay, so remember, a vertical line is x equals, and a y equals is a horizontal asymptote. Okay, so just what they're saying here, and the way that you denote asymptotes on a graph is it's a dotted line like this. Okay, and that just basically means it's going to go up to it, but it won't hit it. Okay, so like if you use a really small value of x, 0.000001 or something, it'd be a pretty big number. Okay. And then, your horizontal asymptote is going to be right here. Whee! Okay? Good times, good times. All right. Okay? So I just kind of want to show you that. Just remember that for all IB problems, at least according to the syllabus, we'll see, is, the vertical asymptote will always be x equals 0. Okay, and again, just take a look at your calculator. You often see asymptotes, horizontal asymptotes on exponential functions as well. And I've done a ton of videos on those. But these ones are a little different. We didn't see a whole lot of those in the last syllabus. Okay, so that was just kind of just to introduce you to it. Now I'm actually going to do a whole problem here. Okay, so this problem says a taxi company's fares depend on the distance in kilometers traveled. The fares are calculated using the formula f of x equals 2x plus 50 over x squared, where x is the number of kilometers traveled. X cannot equal 0. Obviously, x cannot equal 0 because right here, it will give you an error. You can't have 0 on the denominator. And f of x is the fare in euros. Okay, no problem. So sketch the graph from 0 to 20, okay? Well, okay, so again, they just want us, they want the graph. Oh, that was such a good line for a second there. From 0 to 20, and I'm gonna do a better graph on the next problem, but I just want to show you this real quick. So, window, they want us to go 0 to 20. Okay, and I'm gonna go y equals. Clear this out, and I go 2x, what is it, plus 50 over x squared? Okay, so plus 50 divided by x squared, okay? And I'll graph it and see what we got. What is going on here? Window. Okay, so what do we want? Minimum, let's see, well, the y minimum, it's going to be 0, so you're not going to have a negative fare. And I don't know, 20. Let's see if this gives us something. Yeah, what did I do this right? 2x plus 50 over x squared. Let's see. Ah, there we go. Okay, so I couldn't see it. Okay. Oh, wow. Okay, there we go. Wow. Okay, so there we go. Okay, so again, as this is the horizontal or the vertical asymptote here, this is going to look something like this. Okay. Now, the vertical asymptote, so we have, x here and f of x here. The vertical asymptote, again, is x equals 0, okay? Now, find the cost for the journey after 10 kilometers. Okay, well, let's do this. So f of x, f of 10 will be 2 times 10 plus, 50 over 10 squared. Okay, so we can actually do that in our heads. 20 plus 50 over 10,000. I don't want to do that in my head. So I'm going to go back here. So I'm just going to do, I can calculate here because it's within our range. So I'm going to go second, calculate value when x equals 10. And it's 20.5. Okay, 20.5. No wonder, because it's 10 squared, not 100 squared, you dingbat. Okay, so I was going to be like, what? Okay, so it's 20.5. Okay, and that's euros. So, give the euro symbol. Okay, great euro symbol there. Sorry for all the European people who use euros and are offended by that. Okay, find the number of kilometers traveled to give the cheapest fare. Okay, well, okay, so for the cheapest fare, that's going to be the minimum here. So again, just, you look at your graph here, the minimum is going to be right there. So I'm just going to go to second, calculate right here. And, you're starting to see a pattern here. Like all these problems are pretty similar. Okay, so I'll just go to the left of the minimum right here, the left bound. I'll go to the right of the minimum right here, and I'll right bound and guess, and it's 3.68. So basically you want to go 3.68 kilometers to get the minimum. Okay, so 3.68 kilometers, don't forget your labels. Okay, so that gives you the cheapest fare. Okay, so, again, not a big problem here, but it can get a little weird. Okay, now, I'm saving up for last. This last problem, there's a lot of stuff going on, and I'll actually do a legit graph, okay? All right, so let's do it. Okay, so for this last problem here, this one's, man, the first time I did this, I messed this problem up, to be perfectly honest with you. Because what happened here is they go, okay, the diagram represents an open container. Okay, that's kind of big, with a capacity of 3 liters. Okay, so okay, no problem, 3 liters. Now, the base of the container is a square, the size of x, the height is y. Okay, no problem. Write down the volume of the box in centimeters cubed. Okay, this is where they're starting to, this is, okay, so they went from liters to centimeters cubed. Now, okay, so this is just a conversion you should remember, that 1 milliliter equals 1 centimeter cubed. Okay, so in this case, 3 liters is going to be 3,000 milliliters. Okay, so in this case, 3,000 milliliters is going to equal 3,000 centimeters cubed. Okay, now there you go. Okay, so like if you didn't know that right off the bat, that would kind of mess you up a little bit. Okay, so write down the volume. Write down the volume of the box in centimeters cubed. Okay, so we got that. So that's A. So 3,000 centimeters cubed. Okay, I'm doing this one off the top of my head here, so could be a little dicey, not gonna lie to you. Find an expression for the height y in terms of x. Okay, well the volume is gonna be, so for part B here, we would have, wow, that's nice. Okay, so 3,000 equals volume equals length times width times height, so x times x times y. Okay, so it's gonna be 3,000 equals x squared times y, so I'm gonna divide it by x squared. So y equals 3,000 over x squared. So this is kind of like a calculus problem where they have you change everything up real quick. So that's what y equals, okay? So that's the answer to part B here. Now find an expression for the surface area. Okay, so the surface area is just going to be adding up all the sides. Well, with x times y, we have 4 of those sides, okay, with x times y, and then we have 1 on the bottom. So the bottom, remember it's open, so the bottom is going to be x squared, x times x, and then it's going to be 4 times x times 3,000 over x squared, because there's 4 sides that are going to be x times y. This is xy, this is xy, the back is xy, and that's xy. Okay, so those are the 4 sides. Okay, so now we get the surface area is going to be x squared plus, what do we got? So that's going to be, what, 12,000. One of the x's is going to cancel, this x is going to cancel out. That's going to become just x. So It's going to be 12,000 over x. Okay, so there's the surface area. Now complete the table below. Give your answers to 2 significant figures. Okay, no problem. So we would have to enter this in. So right here, okay, so I'm going to just go clear it out and go x, not squared, clear it up. Okay, so x squared plus 12,000 divided by x. Okay, and let's just go to the table. Now, what do they want us to go by here? They want us to go by 5s. Okay, you can actually change the table up if you want, and I'm going to show you that. So I'm going to change it up here. I'm going to go by 5. So the way you do that is you hit the plus sign, and I want the change in table to go by 5s. Okay, so I got 2,400. Okay, so, ooh, this is going to be tough to fit. Okay, let me just write it in. I'll be back in a second. Okay, so what I did is I went through and I just, I looked at the table. Oh, it's been so long. I made a graph too, so that's why it's taken so. So I looked at the table and I just rounded to 2 significant figures in all of these. Okay, now what I did is I copied this table down here because I'm going to graph it. It says draw a graph for A, where 0 to 35, use a scale for 2 centimeters. Okay, so this is key, man. 2 centimeters right here. 2 centimeters. Why can't I use my pen? 2 centimeters. 2 centimeters to represent 5 units. Okay, so that's 2 boxes, and then 1 centimeter to represent 400 units. Okay, so what I'm going to do is I have my graph here. So 2 centimeters is going to be 5 units. So it's going to be, you know, every 2 boxes, 5, 10, 15, 20, 25, 30, 35, 40. Okay, and you know, don't forget to label it. So what is that? That's x in centimeters. Okay, so you got to make sure you label this. This is how you get all these points. Okay, and then what do they want? 1 centimeter represent 400 units on the vertical axis. So okay, so no problem. So 400, 800. Okay, sorry, this is a little hard to see. 1,200, 1,600, 2,000, 2,400, 2,800. I think that's all we need. 3,200. Okay, and what's this? It's a of x in centimeters squared. So a of x, and that's centimeters squared. So that's the area. Okay, and so then what we have to do now is we have to go ahead and graph these. Okay, so you know, you get 5, 2,400 is right here. 10, 1,300 would be, so these are going, let's see, it's 400, so it's by 5, it's going by 80. Okay, so you're going to have to guesstimate here. So 1,300 is probably a little bit right here. 15 is 1,000, so that's going to be in between, right in the middle here. Okay, this 20 is 1,000. Okay, so 25 is again 1,100. So again, something like right here. 1,300 is just one more up. So let's see. So it would be 1,280. Yeah, 1,280, 1,360. So again, it's just kind of like right. Oh, that doesn't look right. 1,300. 30 is 1,300. 11. Oh shoot. Okay, so this one's too low. Okay, so that's 1,100's right up here again. Okay, so that one's wrong right there. Okay, so you see how I'm graphing these, and I realize I screwed up. That's actually a good lesson there. And 35 is 1,600. Okay, so let's get the eraser out, and see ya. We're gonna get rid of it. Bye. Okay. Okay. So if we're gonna draw this again, it would look something like this. It would be like, wee. Okay, so. Again, something like to the effect of this, okay? You want to make a smooth, ooh, wow. You want to make a smooth line. So, again, this is why you always draw your graphs in pencil, okay? Because look at this. This is an absolute disaster. This is what not to do on an IB exam. This is what I'm teaching you. This is what this video should be called. How to Make a Crappy Graph by Rick Parina. There you go. Okay, actually not that bad. I've made worse. Okay, so there you go. Would I get all 4 points on that? Yes, I think I would. Igor, the IB examiner, would give me all 4. I don't know. Maybe, probably not, but it's close enough. So you get the point, okay? So the point is to label your axes and draw your graph. You'd be good to go. Okay, now let's see what else do they want. Use your graph to decide if there are a value of x that makes the surface area of the container a minimum. And if there is, write down the value of x. Okay, well, yeah, there is, and it's down here. Okay, so what we want to do here, okay, I would, again, I would solve this using the calculator. Now, we're going to have to play with our window here. So we're going to go, let's say, 0 to 40, and we're going to go by 5s. Okay, and then the minimum, y minimum is 1,000. So let's go up to, like, say, I don't know, 4,000. You can go by, I don't know, we don't want too many. I'll just go by 500s. How about that? Or, no, oops, sorry. So the y minimum is 0, whoops, 4,000. And I'll go by 500. Okay. And, you know, let's did I enter it in? Yes, I did. And I'll graph it. So not bad. I mean, mine kind of looks like that. Okay, so the minimum is going to be right around here somewhere. So again, let's find the minimum. Second, calculate, and we will go minimum. Boom. Okay, so let's look at 20, left bound, 999, okay, 1,000. So, okay, so it's 1,000, 1,010, 1,003, 998, 994, 990, 991, 996. Okay, so the minimum's in there somewhere. Okay, so let's left bound, I'll just go right here. And right bound, I'll just go over here somewhere. And let's guess. And so at 18.2, you're going to have a minimum at 990. Okay, so your minimum here is going to be 18.2 centimeters. All right, and there you go. That was a long haul, but it's not a bad problem, actually. That's a pretty good problem. So I did a graph on that. I had to rearrange stuff. I had to use a minimum. And had to use some algebra here to cancel everything out. So you got a lot of functions, man. Anyway, I hope this video helped out. Kind of some random problems, but again, get used to your calculator. You'd be all right, okay? Best of luck to you. Take care.